What is the difference between pessimistic locking and optimistic locking? What are those terminologies? We're gonna find out today. So I have made this kind of small presentation about what is locking. So this guy wants a ticket, and this guy or woman basically wants also a ticket. So both of them want it. So what is the problem here? There is no problem. It only happens when it is the last ticket. So if it's the last ticket, only one person is able to do it, and this person can be this one, can be this one. Who knows? So what happens usually in the database? Hey, you're some kind of issue. So basically the database handles. Maybe it overrides it. Maybe there is some kind of race condition. Maybe it handles the locking by itself. We're gonna figure out now in this video. And also maybe there is some kind of isolation levels that solve this problem. At the end of the video, we're gonna be finding out a bit more about the isolation levels. Okay, so now we're gonna be looking here into this simple demo application in order to identify what's happening and how can we understand more about the locking mechanism. So first I have two tables. One is event, one is booking. Basically the booking is just a booking for an event that we have, and the event has some certain capacity and there is some available seats here. So basically the goal is to reach 0. If basically we have reached 0, then basically there is no more seats, or basically the idea here, no more tickets. This is basically the two tables that we have. I'm gonna open the booking right here. This is simply it. Nothing fancy here. If we went to the event here, you have the capacity, available seats. The only point that I want to mention here, we have version. The version here is introduced for one reason, which is in order to make use of optimistic locking. So the moment that you introduce version here, this means you're most probably gonna be working with optimistic lock. This is why you have this annotation. And we have also event without version, but to be honest, it made like too much overworking. So basically, if we remove this version, this means you're gonna have the simple DTO without really optimistic locking, and we're gonna find out really soon. So I'm just gonna delete it because it's not really needed. So what happens now is we have an event repository and booking repository. Booking repository is simple. We just find by event ID, we provide the event, and we get a list of bookings related to this event. And we have the event repository. We have the explicit pessimistic right here. This means we're gonna be locking the row and to make sure that no one is able to write while we're writing it. This is like you're blocking anyone who's trying to access this record. And another approach is using the event snapshot. This is without the version. This is not another approach other than this is one of the methods that we have. Like we have another method or basically another method to mimic the behavior of the non-version one, which is basically the normal behavior. Like if you don't really have a specific way of working when we're talking about if you're not handling pessimistic approach, if you're not handling optimistic, if you have no isolation level, you're just working. So I just wanted to mimic this kind of behavior, so I introduced this interface that have no version because I don't really want the version here because for the sake of this demo. And eventually the last method that we have is update available seats. That's basically we're just updating the available seats by one. We're decreasing it by one and updating. And the calculation happens in code. So we have in the controller here, we have multiple by the way, this project is not really best practices regarding too many aspects, but because its main purpose is just presenting the locking mechanisms that happen in our database, which in our cases are optimistic versus pessimist. Don't forget the isolation level that I'm going to be speaking at. So for the post mapping that we have, we're creating an event. We can get a specific event. We can also get the bookings related to specific event, and eventually we're going to be creating a new booking regarding a specific event. So yeah, we have a couple of modes here. If the mode is either one of them, we're gonna be this mode is provided to us by the controller itself. Like we're gonna pass it in the kernels that we're gonna be using. And if it's gonna be plain, then we're gonna be working with the plain. Optimistic, we're gonna see it right now. Pessimistic, and eventually this is an isolation level. So let's start with the plain one. The plain one, hey, we're gonna be creating a transaction here. This transaction, we're returning this event snapshot. This snapshot is without the version. So we're gonna be getting out this normal behavior, finding this snapshot, get the available seats, and if it's less than 0 or equals to 0, then basically no seats are available. Then we have an artificial delay. This is like a hard-coded 5,000 milliseconds, which is basically 5 seconds, in order to have some kind of space in order to mock this race condition, because otherwise I would be making breakpoints, and we can do breakpoints, but just for the sake of simplicity here, I made this 5-second delay. And now the new available seats is less than what was available because we have basically supposedly taken it, and we want now to update the available seats. And eventually we're gonna be updating this booking with the new bookings that we have. We need to store the new bookings that we have related to this event. That's basically what we have done for the plain one. It's a booking for the plain. The optimistic approach one, which is another approach, we're gonna getting the whole object, the whole event. This means the version with us. We're gonna be getting also the version, because when you're querying in optimistic locking, by default Spring takes the version with you, like it compares the version. If there is multiple differences in version, it throws an exception. This exception is called optimistic locking failure exception. This happens when, hey, another request is trying to access a row that was updated. So you basically have an outdated row. You need to have some kind of retry mechanism in order to prevent this approach. So basically that's how optimistic locking happened. So let's continue. We're gonna be getting the event. We're also checking the balance for available seats, the same artifact delay, and here we're gonna be getting the old seats and the old version, and those are what we're gonna be printing here in order to show you what's gonna be happening. And then we're gonna be setting the event, and eventually we're gonna be saving it. You can save or save and flush. It wouldn't really matter since we're gonna be working in transaction. But the difference between save and flush, the flush is an IO operation that's happening in operating system. If you most probably know, the operating system has this IO operation, which is basically for flushing. This means that we're gonna be persisting the data into the database, because in what happens normally is, hey, you're gonna be saving it in memory. This we're calling it like nanoseconds, maybe milliseconds, I don't know, but I'm pretty sure it's almost nanosecond, couple of nanoseconds. And then you're gonna be saving it in the hard disk, in the SSD or HDD. And when it happens, this process, this write on the disk, this happens due to a fact of flush. This is the flushing that happens. So save and flush, this means, hey, you're gonna be writing it to the hard disk. And by the way, this doesn't really mean the transaction above will cancel, will override this transaction approach. This means, like, for example, if there is some kind of exception that happen here, like if let's say some exception happens that caused like this, this will cancel that transaction, will roll back here. Like this will happen. Say roll back. Okay, nice. Yeah, it will roll back here, and yeah, that's basically, it's gonna be rolling back just fine. But that's basically the idea of flushing. So it wouldn't really matter if you save or save and flush. Save and flush just will make it more faster to break things, like in order for this demo. That's basically yeah, and eventually we're gonna be saving the booking, the new booking related to this event. And basically this is the optimistic approach. Now we're going to the pessimistic one. The pessimistic approach, this is an explicit locking. What I mean by explicit, if you went to this find by ID for updates, you're locking this row. This is specific record you're gonna be locking. No one else is gonna be able to work with this record unless there is yeah, no one needs to work with this record, because you're technically like you're saying, hey, no other thread, no other thing, there is no other thing that's gonna happen to this record other than what I'm doing right now, due to the fact that I have this lock against this record, this row. So you're getting this event, and you're gonna be doing the similar processes as before. Eventually you're gonna be saving it, and that's basically the same approach as before, which you have seen. The only difference is, instead of explicit version outside, you're using the locking here. That's basically what's happening at this point of time. That's for the pessimistic one. And yeah, that's basically the locking mechanism that we have. And I'm gonna be starting the demo right now. Let me run. I have also, by the way, I'm using Postgres versions we have, and this is the SQL that we have. We are creating those two tables and inserting an event record. And yeah, I have also Docker file in order to run this SQL from. Also, I'm building it from Postgres 17. You can do whatever you want, and I have Docker Compose just to make things faster here. So I'm just gonna make Docker Compose up. Okay, so database system is ready, and now let's do what we're gonna be trying to do. So first we're gonna be trying the plain demo. This is the curl that we have in order to insert a new element. So basically I already have an event at event here. So basically if I did this, let me remove all this. So if I get like this last event, okay, I haven't really launched this log application. Okay, on my back. So yeah, after launching it, the most probably it launches now. Yeah, it started. So I'm gonna be clearing it. I'm gonna go to the terminal, clear this terminal. Great. So now I'm gonna be curling the first element at this ID. So we have an available seats of 1, which is basically what we had inserted in this init. This is the available seats. And now what do we want to do is we want to have the plain approach. Here I'm gonna paste both of them in two different terminals. This means that we almost have two different users doing the same behavior. So now I'm gonna be running both, and if we're understanding correctly here, the plain approach might be causing a problem. Why? Because potentially here in this booking service that we have, we're starting a transaction at the first terminal, and it's gonna be reading a snapshot. This snapshot contains an ID and available seats, and since it's available seats, it's gonna be reading some data. And when we run the second second terminal, we're also gonna be finding out, hey, it is also reading the same value. So basically we're gonna be having two users who are trying to do the same behavior, almost identical, but two different users. This means this is a problem that we have, right? Two different people trying to access last ticket, and only one of them needs to have this kind of access. So this is what we're gonna be doing now. Let's run both of them right now and see what happens. Do they override each other, or what happens? Okay, so first one is success, second one is also success. How does it happen? Doesn't really make sense. Shouldn't happen. This means two people have the same final ticket, which isn't really open. This is the problem that we have. This is the main big issue. It shouldn't have happened. So the solution here, we're gonna be trying out the optimistic solution. So if we try it, by the way, to get this curve for this one, and we'll find out, hey, the available seats is 0, even so it should be -1 because two people took the last available seats, which isn't really making any sense. And if we want to get the booking here, you will find out, hey, we have two. Like I want to just to show it, like we have this user 1 and we have also this user 2. Like those two are related to the same event, which is basically this event, which is the only event that we have. This is basically the problems that we have, because this doesn't really make sense. This is not right. We have only one. We should have one booking. So let's clean this up and try our second approach. Let's see how the optimistic locking would work. And by the way, we can view the logs here, because if you want to, I have some kind of login. So what happens here, we have taken, like we also notice that we have two threads. We have -3 and -2. So what happens is, let's search for trace ID, because it would make sense here. So this is the first request I believe that we had. Yes, this is the first request. We booking a request received. We have taken it and completely until eventually we're writing a new seat. Old is 1 and the new is 0. This is the last, I believe. Yes, and eventually the booking was saved. Yes, so that's what happened. And then let's check the second thread. Second thread started the request and waited a couple of seconds, which is basically 5 seconds, and then it woke up and continued and writing new seats. All this one. This is pure race condition issue. This is like if you're working in multi-threaded environment, this is the case that most probably you're gonna be facing, and you need to be aware of. So yeah, so what is the solution now? Let's clean this, and we have our terminal ready. Okay, so now I'm gonna be taking the new, I'm gonna be creating a new event. This event is gonna be with ID2. So let's use this ID and see what's gonna be happening. Okay, so yeah, we have available seats of 1 for this ID, which is 2. So I'm gonna be taking this one and also this one. The only difference here is users. So what happens now, I'm gonna start user 1 this time first and then second. Okay, so now I have run both of them, and if I've seen this one here, we'll find out, hey, user 1 requested in this thread and user 2 is requested in this thread, which is completely fine. Two different threads, two different requests, both happen concurrently all together with each other. Like you see, like they are overlapping within each other. So what happens now, let's see, get batch 2, which is user 2 concurrent update you to optimistic mode, and the first user succeeded. That's basically due to the fact that we had the version. I want to show you the version here. This one, this version where ID is not this one actually. Okay, this is starting and booking flow. Yeah, this is the find the query first. So this is the find by ID one. So this is, we only need the find by ID. Then when we're trying to update, this is the update that's happening. We're updating where ID and version. Even though we don't really mention the update. Where is this update? Yes, we're in saving and the flush. We got the event and we have modified the event, and now we're gonna be updating the event. And since we're gonna be updating the event, Spring by default uses this add version annotation in order to include it in the query that we have. So in the update behavior, when we're trying to update, we're gonna be considering the update for this specific version. So if the new version or there is a different version than what I had previously stored, this means we're gonna be having a problem, and this is why it happens in the second user that we have. And let's walk through what's gonna happen in the first thread. So first thread, booking request received, starting a new booking flow, read event, seats is 1, version is 0, completely fine. And let's wait 5 seconds. After this 5 seconds, we woke up and continue trying to update. The old seats is 1, the new seats is 0, expected version is 0. So basically now we update. What happened after the update is event updated successfully and the new version is now 1. Okay, so this means that we have entered it and the user eventually stored the new version with value 1. So now what happened with the new or later user, like user number 2. First request is started. We started the booking flow. We have read the value. We find out the version here is 0, which was similar to the previous version. Like the first user has a version 0. So now we're gonna do our work, which is basically wait 5 seconds and then walk up and continue, and we're gonna be trying to update. The fact that we're gonna be trying to update, but previously we had an updated version of 1 and it is expecting 0. So there are two different versions now. Two versions. Since we have two different versions now, this isn't really right, and we're kind of, hey, this is something wrong. Optimistic error happens, and this exception we catch it here, and this is why you're viewing this error message. This is the optimistic handling for this case, due to the fact that we had a version. Yeah, that's basically for the optimistic. Let's clean up this one, and let me clean my terminals. Okay, so now the last one is pessimistic approach. What happens here in our event repository, we have explicit locking mechanism. So we want to lock this record. No one is able to touch it unless I'm finished with my work. If someone tries to touch it while I'm working with it, will not be working as expected, and hey, you throw an error. So what happens is I'm gonna be creating a new one. This one will be ID 3. This is ID, the new ID. So now what I'm gonna do, I'm taking this curl, run it. We have this available seats of 1 expected, and now I'm gonna be copying both user 1. I'm gonna put it in the first shell. User 2, I'm gonna put it in the second shell, and now I'm gonna be running both of them right now. Let's see what's gonna happen. Okay, so let's run. I forgot to clean, unfortunately, my previous log. I think so, right? Or I cleaned it. Nice, I cleaned it. So yeah, I didn't really forget. Okay, so what happens now? Let's view the terminal first. The second seat say no seats available, no seats left for 109. Why does it say? And for first terminal, it booked successfully. This means when we try to, in the booking service, in the pessimistic approach, we're using the locking mechanism. So the first user came in and logged this event. No one is able to access this record, and when no one was able to access this record, this means we're gonna be preventing any other thread, any other potential user who's gonna be trying to access this thread. So we're gonna be somehow you can think of, no one is gonna be working with this record unless I complete my work. So what happens is the first thread continues to log this one until it completes, or basically completes his work with this row. And after completion of this row, when it's eventually done, then you can continue with the other user or other thread. So this means the second thread goes here and, hey, I want to find this event. He's gonna be able to find it, and then we're gonna be getting the available seats, which is basically less than or equal to 0, which means, hey, this means we're basically done, and this user is not available to have any more more seats, because hey, now the available seats are 0. And this is what should happen in the logs here. This is I'm expecting. So let's start with this thread. I'm gonna put it here. Okay, booking request received. Starting booking request, waiting to acquire row lock. This is the pessimistic one. This is what happens, and then we're gonna be row lock acquired. Great, the seats available is 1. And by the way, if you have noticed, we have for no key update. This is SQL statement. This is a SQL. Like you can do that in SQL statement as well. So yeah, we're gonna be seat available after lock. We're gonna be waiting this 5 seconds as an effort. And by the way, we have we have taken this another request, but it is blocked, or basically it's waiting until the lock to be completely released in order to acquire this lock. That's basically the main point here. So we woke up and continue, and after updating, after we completed the update successfully, and then the transaction will now be released, and the lock will be unlocked, and now other threads can be using the records that we had logged previously, and we can use this using the second thread that we have. Let's begin. We begin our request here after basically we're not after in concurrent with the previous request. Started booking flow, waiting to acquire lock. You're not gonna be wait to until the first thread to complete until you continue. You will find out this is exactly what happened. This is exactly what happened. You waited for the transaction to be completed, and then you're gonna be allowed to access the record here. But guess what? Booking rejected after lock, and the reason was no seats available, which happened here. This is basically how you handle the pessimistic approach. That's the locking mechanisms, by the way, optimistic versus pessimistic. Hopefully you enjoyed the content so far, and I don't really want to leave you out here hanging, because there is one more tip that I want to be discussing, which is isolation level, that's somehow related to locking. It's not be directly related, but it's gonna somehow correlate here. So what happens here is in isolation levels, we in Postgres by default it's gonna be using read committed. Let's show you here. A read committed is some kind of isolation levels. That means you're gonna be allowed to view whatever is committed. There is also multiple different isolation levels, such as read uncommit, such as serializable, and there is one more isolation level that is called, I think it's called different databases, so you can search it up, but it is related to Ghost. It's phantom read, like you don't really read, or actually you read the uncommitted, as far as I remember, uncommitted updates. So basically you have some kind of yeah, I'm not sure, to be honest. I need to revisit this phantom one because I keep forgetting this kind of stuff. But yeah, there are multiple isolation levels, and you need to be aware of what isolation levels that you're going to be using in what database, because each database have different isolation levels. So in Postgres we have read committed, so you need to be aware that in your database, in your isolation level, the read committed, you need every time you're reading data, you're reading from committed data. So basically if you have two different transactions, one is committing stuff, but the transaction is not finally completed, it's not finally committed. If the transaction is not finally committed and completed, then you will not be able to view it because it's not you need to the transaction to be committed in order to view. So yeah, so I want to speak about the serializable isolation level. This is somehow related to the locking, because I feel like it's really important, especially if you're working with some kind of data that you really need to have in order, or basically you need to have some kind of sequence, you need to have some kind of accuracy, some correctness. This is when we're talking about isolation level, and you really don't need to understand every single isolation level on earth. Like you don't really need it. Just know the famous four, which is read committed, uncommitted, isolation, serializable, and phantom, which I had forgotten. So yeah, we're gonna be talking. Let me just switch right now. Yeah, I'm back here with the serializable booking service. This serializable, by the way, we have at an isolation level on the transaction. It's not on the locking. Like it doesn't really happen on the lock. It happens on the level of the transaction itself. Like we can think of like the locking happens on the record, and the transaction happen, and the isolation level happen on the transaction as a whole. Like whole transaction, whatever happens here. So you can think of in those two different areas. What happens in the serializable, we're gonna be finding by ID, which is basically similar to what we had previously. Like but we had like an explicit method, but basically we have a find by ID that's basically returning an event, and this event we're gonna be checking if it's available seats. It's less than 0, we're gonna be logging error, some kind of error happen, and the same logic happen. We're gonna be waiting like this 5 seconds. Then we're gonna be updating, eventually saving it, and yeah, that's basically what we're gonna be doing here. So yeah, let's try it out here in our demo and see how it's gonna be working. It should supposedly work similar to the Pessimistic, but it's gonna be a whole different way of implementation. Like this is on the level of isolation, and there is no, like if you find by ID here, there is no like locking happen. Like we don't really use this locking happen. Okay, so that's basically, where is this serial? Okay. Yes. Okay, yes, in the serializable here, we're gonna be taking this and we're gonna be creating a new object. This one will be at 4. So let me clean up the logs here. Okay, I'm gonna be creating this one with ID 4, available seats 1, which is amazing. So now let's clear this up, and yes, copy. We're gonna be clearing this one. Okay, so shell 1, user 1, and shell 2 is user 2, and both of them are serializable. Let's see what happens. Everything is cleaned up, and we have an insert statement due to the fact, hey, we just inserted one. Let's run both terminals right now and see how it's gonna be working. Okay, so I'm running both of them now. Let's see the response. One of them, which is the first one, booked with serializable mode successfully, and second one, serializable transaction conflict detected, and we need to retry. And this is something that happened due to the fact that, hey, we have some concurrency failure exception that was catched here, and this is why Postgres kind of we can think of it like we have cancelled this one transaction to keep the execution sequential. And if we have checked the log right now, we should view what we have just mentioned. This is the first user, I believe. We have received the request, read an event. Okay, we're gonna be sleeping for 5 seconds just for our work, and when we woke up and continue, we're gonna be trying to update. The old seat is 1, the new seat is 0, and eventually it is saved successfully. Okay, this is basically what happened, and you see that in parallel another thread was working with us. So let's again with here, we have also initiated a request, started booking flow, and we're reading event. We're finding out, hey, the seat is 1, but wait a second, you're not gonna be able to do anything until the first transaction completes. So that's basically what happened. You woke up and completed after the first transaction completely successfully saved and ended. So the moment that the transaction completed, then we can continue. This is why we woke up and continue after the previous transaction. So now we're gonna be trying to update. The old seed is 1 and new seed is 0, and we know as a matter of fact this one is wrong. So here we're saying booking saved successfully, but this was not the case. We have thrown an error here. This is something that's saying, hey, this doesn't really work. How did you do it? Because we could not serialize access due to concurrent updates. This means we're gonna be trying to do different events. We're gonna be trying to do different updates within the same, like in parallel in the same time, which isn't right. So serializable here throws this concurrent failure exception to prevent this approach, and this is why you have seen this exception thrown, and it was catched here to prevent this problem. And this is an example of how an isolation level can help you when you're deciding how can you work with your database. Hopefully you learned something. I'm not sure, to be honest, if this is a beneficial video or not. This is my first time trying to do this, but if you're interested in this kind of videos, feel free to comment out. And if you like me to do more videos about isolation levels, databases, maybe message you. If you want me to speak about the differences between isolation levels, feel free to do so, and tell me what your thoughts about this video.